What's up? So today I'm going to be talking about something that I talked about a pretty long time ago in the past, but since then I revisited it a few times over the months, and now I think I've gotten it like perfect. Like I don't think there's any good way to improve this from here. And what I'm going to be talking about is exactly what the title says, which is how to find the scramble for any given clock state very quickly by hand. And I say by hand because there is and has existed a program for this made by Josh M, where you input where all the clocks are facing, and then it tells you what the scramble is. But that was found, like that program runs using inverse matrices, and it is a program, while this is by hand, and it was found by hand by myself, just through intuition and knowing a lot about how this puzzle works. So, yeah, I'm just gonna get into it. I'm not gonna be talking about why this works, at least today, but just how you can do it for yourself. Basically, the idea behind what we're gonna be doing is we're gonna be solving the clock using a pin order that's just the inverse of the scrambling pin order. So like we're gonna start with the all move, then L, then D, then R, then U, flip, all, L, D, etc. So starting with our all move, for example, if we calculate it to be +4, we know our scramble ends in all -4, and we just go from there. So to start, we're gonna look at our center and multiply it by 3. In this case, we're at -4 times 3 is 0. Then we're going to subtract all of our edges, and by that I mean whatever the edge needs to do to get to 12, we're going to apply that to our center. And then wherever our center is after all 4 subtractions is what our all move will be. So we're at 0. This needs to do a -5 to get to 12. So we do a -5. We're at -5. This is already at 12, so we're still at -5. This needs to do a +1 to get to 12. So we do a +1. Now we're at -4. And then this needs to do a -5 to get to 12. So we do -5. Now we're at 3. So 3 is our all move. The edge moves are super easy. We just match the center to the opposite edge of what pins are up. So like when the left pins are up, we just match C to R. When the D pins are up, we match C to U. When the R pins are up, we match C to L. And when the U pins are up, we match C to D. And if we did everything correctly, you should have a cross all pointed at 12. Then we flip Y2. You can flip X2, but I have everything written in Y2 because that's how you scramble. The second all move was definitely the hardest part to get efficient and is the hardest part of this solve, but it's not hard. I've over like all the times we come back to this, I think I've finally perfected it. So we're gonna look at our center, and we're just going to add all of the corners and subtract all of the edges. And then that's gonna bring our center to some point, and whatever that point needs to do to get to 12, that's our move. So we're starting at 2. This is a -3, so we do a -3, now we're at -1. This is a 1, so we do a 1, now we're at 0. This is a 6, so we add 6, now we're at 6. This is a 0, so we don't do anything, we're still at 6. Then we subtract our edges. So this needs to do a -4 to get to 12, so we do a -4, now we're at 2. This needs to do a +5 to get to 12, so we do a +5, now we're at -5. This needs to do a +6 to get to 12, so we do a +6, now we're at 1. And then this needs to do a -4 to get to 12, so we do a -4, now we're at -3. -3 has to do a +3 to get to 12, so our all moves +3. Next is the edge moves. These also took a very long time to become efficient, but now I've gotten them super easy. So we look at the edge that corresponds with our dials that are up. So we have the less dials up, so we look at the left edge, and we look at the corner that's further along clockwise. Whatever this edge needs to do to get to here, in this case a +5, we bring the other corner that's correlated with our up pins to the opposite of that, so -5. And we do the same thing for all the other edges. So this needs to do a +6 to get to here, so we bring this to -6. This needs to do a -1 to get to here, so we bring this to +1. And then this needs to do a +5 to get to here, so we bring this to -5. And then from here, it might look pretty scrambled, but we actually just match all our corners to 12, and then we're just done. Oh. And there we go. It's just solved. I'm going to run through it again without speaking, just to kind of show it again. Okay. Like, look how easy and fast that was. So it's just super cool. But let's say you're watching a video and you see a clock and you want to find what scramble it is. Obviously, since you don't have it in front of you, you can't do your calculations move by move like we just did there. You need to do them all in inspection. How can we do that? Well, I have a list of calculations that I basically found using this just by incorporating like where each thing will be for each calculation after what we've already done. And it's like 95 calculations long, but that it will serve that purpose of finding the scrambles for like clocks and videos that don't have the scramble listed. Overall, I think this is very cool. Like I said, I'm pretty sure I have it like perfect now. I really don't see how this could be better. So I don't think I'll be coming back to it again, except for maybe like speed solving it more. For speed solving though, you have to do your like second side all calculation in the solve. Doing it in inspections kind of impractical, I feel. Like maybe not, but then you just have to do the edge ones in calculation or in the solve. I think they are pretty look aheadable, but like if you got like a cross skip on one side, like pointed to 12 as well, or like at least an almost cross skip, then you could probably do like all of your second side calculations in inspection, and you could get like a 5.6 or something. Yeah, that's basically it. This is just a rant video about this. I might have more rant videos in store because I've been thinking about a lot of theory regarding this event recently, but that's all for today. Bye.